Hello, my name is Rachel Hackett, and I'm a graduate student at Central Michigan University, and I study prairie fen wetlands. Prairie fens are this dynamic, groundwater-fed ecosystem that houses a large amount of biodiversity. They're one of the most biodiverse ecosystems in the temperate region. These ecosystems can harbor up to 50 different threatened and endangered species, including the Poweshiek skipperling.
When I learned about prairie fens, I was very interested in the fact that they had this very limited distribution in the upper Midwest and that they had such a high level of diversity. And so when Rachel first came to me as a potential graduate student, we looked at different ways that we could measure the biodiversity in these systems, potentially looking at what's driving this diversity or what might be limiting this diversity or changing the diversity in these systems. And at the very base of it is we have to understand the species that are there.
To answer this question, we chose plants as our study organism, our community. Plants are the primary producers of these systems. They respond to the hydrology and the soil of the systems, and they are also often used as indicators of the comprehensive biodiversity at sites. So we had to devise a method in order to consistently collect representative biodiversity at each of our sites. So we collected each specimens, we used quadrant transect methods, we vouchered each species we came in contact with. We made note of all the specimens that we found in each quadrant, and then we tested our sampling method. We evaluated it for representation of the biodiversities of these sites. And we found that we were consistently collecting about 90% of the plant species at each of our sites with our sampling method. So over several years, we've collected prairie fen data at 29 different prairie fens in Michigan. But there are over 150 different prairie fens just in Michigan alone. This is not counting the rest of the glaciated Midwest. So in order to expand prairie fen research, we'd either have to get a lot more bodies, or we have to find another way to detect some of this diversity. And we turned to remote sensing to see if using remotely sensed imagery could provide us with some of this plant biodiversity data. We collected at several prairie fen Michigan sites via drones, and we flew drones over the prairie fens and collected multispectral 10-band imagery.
But at the foundation of all of that is we needed to document it. And so documenting it meant taking care with creating a database that could function in perpetuity for our lab so that we could go back and access it, that it retained the information, that it was searchable. But it also meant getting voucher specimens that we placed into the herbarium so that those could be accessed again at another time. They could verify that we knew what we were talking about when we said we saw this species in the system. And then we could ask other questions about it, even down to what sort of herbicides or pesticides might be present within that specimen. So we have the voucher specimens, but we really needed to think about the database that we were developing because we wanted to be able to build on that over time, both to add additional prairie fens, but maybe even add additional taxa, to add data layers that related to the soils and the water chemistry at the site level, as well as the landscape level variables and land use that was occurring around the fens. And we even added in some remote sensing to see if we could pick up some biodiversity sort of detectors that could allow us to scale up and start looking at more and more fens, but using remote sensing to do that.
So we pushed a lot of this data online to a Midwest Herbaria Symbiota portal in order to give future researchers that might be studying these systems or these organisms, to give agencies that we partnered with access to the data that we collected.
Rachel's project had a couple different aspects that benefit the work that the Nature Conservancy is doing on prairie fens. First, she was sampling the plant diversity in the fens that we manage, and that's always useful to us to have that data to document the benefit and validate the restoration techniques that we implement on prairie fens. So by documenting that there's high biodiversity as a result of our restoration actions, that just provides additional justification for the work we're doing and validates the work we're doing. The other element of her project was looking at landscape factors in the surrounding areas that might influence the diversity of prairie fens. And that's useful information to the Nature Conservancy because we work not only on our own property but on property of adjacent landowners to create larger areas of high quality habitat. And so knowing what the factors are in the landscape that benefit the diversity of the fens helps us to decide which restoration actions to implement and how to strategize our work across a larger landscape.
So in Prairie Fens, we found that both site and landscape level factors contributed to the variation we found in the diversity of plants at the Prairie Fen sites. We specifically found that the water and soil chemistry had a lot to do with the arrangement and abundance of the different species at the sites, and that the surrounding landscape and the area and the perimeters of the sites were related to the number of species and the quality of species that we found there.
So the next sort of way we moved forward with the project was to think about other taxa within the system, and that's where the Powashik skipperling came in, and looking at sort of butterfly presence in those systems. And that's where we started to add layers of data, both data from our own field studies where we were doing a carefully delineated sort of survey work while we were out there multiple times during the flight season, but also to look back and start gathering data that had been gathered at other sites, at historical sites, looking at sort of observations over the last 20 years that we could find records of, both within Michigan and across the range of the Powashik. And how are we going to integrate this with the data we already have?
So this project concerning prairie fens started with the graduate student before me, Rachel, who started studying these really cool, unique ecosystems. That really provided a great foundation for me to come in and look at the interaction between the habitat and specifically this Powashik skipperling. My specific question regarding the Powashik was what differences exist between the prairie fens that do have this really unique butterfly and the prairie fens that don't have the butterfly. One of the issues that we run into by studying a rare organism like the Powashik skipperling is there's not many locations where it exists. So historically, there were about 8 locations in Michigan where the Powashik has been in the past 20 years. So we have about 8 locations that we can go and sample the habitat characteristics for that had the Powashik, and then we can compare that to 8 other locations that we have verified that do not have the Powashik skipperling. The way that we sample these prairie fens is we create a sample design where we determine some quadrats beforehand, and we hike out to these quadrats, which are meter squared, and then we identify all of the plant species within that square meter. We collect the floral biodiversity data in these quadrats, and then we can calculate other floral parameters such as floristic quality index, average coefficient of conservatism, and different diversity indices. We can then compare these parameters between these different fens and get an idea of what makes these habitats different, even though they're the same natural community.
Clint's project provides valuable information to the Nature Conservancy in terms of single species documentation of the Powashik skipperling. And that's useful to the Conservancy because we have a prairie fen where that particular insect used to occur but has not the past 2 or 3 years. As a result of Clint's analysis, he may find some landscape elements that are important to the occurrence of Powashik, and by knowing that information, that will help the Nature Conservancy decide how to manage the surrounding landscape and our property to make it more hospitable and attract Powashiks in the future, and potentially use our fen as a reintroduction site.
So we looked at how could we add in additional taxa, additional variables that might even come at different scales. And this is when things really started to get exciting because we had all of our collection-based data for the plants, we had all of our observation data, but we started to be able to go back to the natural history collections and get additional data of plants that may have occurred in those systems. But also we started to look for records of Powashik and Powashik occurrence that weren't part of those observation records that might have been available to us initially. And with the help of a recently funded thematic collection network, we were able to get data from LepNet where we found Poweshiek occurrences that were vouchered not even in the Great Lakes area. So, one of the more interesting ones was from Oregon State, where they had 7 Poweshiek occurrence records that were vouchered with specimens in Oregon, where someone had collected them and deposited them there. And that gives an example of how we started to reach out further and further and find more and more records, even dating back to the 1700s, where these had been observed. And this really enhanced our ability to start asking more nuanced questions about how maybe the distribution changed over time.
So my project is largely built off of predecessors, with Rachel really creating the foundation of the plant work, and then Clint continuing that plant biodiversity project and focusing in more on the Poweshiek skipperling within Michigan. So I was furthering a lot of the questions Clint was asking, but just increasing the time scale of my questions and also the geographic extent of my question. And by increasing this temporal and spatial extent, we needed to bring in different data sources. And these data sources that we were plugging in included historical occurrences, which we were able to get through natural history collections, and through the LEPnet was a great contributor and collaborator to get these sources, along with citizen science initiatives that included iNaturalist observations and notes from nature, where people were able to transcribe museum labels to help with this project as well. Through LEPnet and increasing our occurrence database, we had known of about 240 or so historical occurrence sites, and we have already expanded upon that with 9 new sites, and we've expanded the time frame of known flight periods on a lot of sites, and we've expanded upon when the first known occurrences or the last known occurrence within these sites where they have been found. Another part of my project has been looking at observational studies of the Poweshiek skipperling and what plants they are ovipositioning on, and we have added 2 new species of plants that had not previously been observed ovipositions on. We also are collecting phenology data based off of flowering time periods of available nectar sources, and then relating that to how often they are using those nectar sources within their area. Someday all that data will be accessible to future researchers, and these researchers will be able to ask questions that may be looking into phenological asynchrony between available nectar and flight periods of the Poweshiek skipperling. And by increasing our knowledge of flight periods through time, through our work with LEPnet and our other historical occurrences, we're also able to ask questions of if the flight periods have been shifting over time for the Poweshiek skipperling, and we could also look into if the phenology of flowers have shifted over time. We aim for this project to inform management based off of being able to backcast environmental stressors through time, what may have caused declines of the Poweshiek at different time periods, using our occurrences that we've acquired through our multiple data sources, and then also environmental stressor variables that we'll be putting into our habitat suitability models.
And having that information available is going to help us to make more informed decisions about the species, because a recovery plan is going to have to be written for the Poweshiek, and that's going to be handled by the lead office, which is in Wisconsin and Minnesota. So having his information is going to help us place that information into the recovery plan so we can have more informed decisions for recovery and conservation of the species.
And sort of as we're moving forward, now we're looking at the fact that we have this really good baseline biodiversity data for the plants. We're getting really comprehensive data, or at least as comprehensive as you can, on the occurrence of Poweshiek. And we're starting to layer on the questions we can ask and really think forward to what could be driving the decline of the power take, what's happening in these systems in terms of overall biodiversity, and as we do this, building a data set that can really grow with that and that can be accessed by the people making decisions in the field about how to do conservation and management.
Some of the work the Nature Conservancy is best known for is conservation planning, so deciding which areas of land need to be protected, what species occur there, what the benefit of those particular parcels are to a larger plan. We're always looking for data and species occurrences on those parcels of land to justify the need for conservation, but traditionally specimen collections require that you go to the actual collection to look at them. So getting those digitized where they're all available in one place, they cover a large geographic area, would be a huge benefit to the conservation planning of the Nature Conservancy.
And this is where our delivery mechanism of the data became pretty critical. So we still have our in-house database, but we're able to put some of that data out there, so we have a set of taxa you would expect to see in the system with very precise locations as to where they would be, and that can be accessed publicly for anyone doing management or conservation of that system and looking at the species that might occur within it. And it's just starting. The key is making the database that can build and starting to layer in all these different nuanced layers of data.